Hello friends, welcome to this video on Laplace transforms part 1. In this video, we will see the basic definition for Laplace transform and some simple formulas and how to apply them to problems. Come on, we will move on into the video. So, what is the definition of a Laplace transform? If f of t is a function of t defined for all t greater than or equal to 0, then the Laplace transform of the function f of t is defined as Laplace of f of t is integral from 0 to infinity e power minus ft f of t dt, provided it exists. What do you mean by provided it exists? So does it mean that Laplace does not exist for all functions f of t? Yes, that's true. Laplace does not exist for all the functions f of t. There are going to be criteria for the existence of your Laplace. So the two sufficient conditions for the existence of Laplace for any function f of t is, the first condition is that it has to be piecewise continuous in every interval t greater than or equal to 0. So if I have t to be the time period t greater than or equal to 0 and I consider an interval over here, the function has to be continuous in this particular interval, or it has to be piecewise continuous in this interval we have taken for. So wherever we take this interval in t greater than or equal to 0, the function has to be continuous in that particular interval. So that is what we call it as piecewise continuous in every interval for t greater than or equal to 0. The second thing is that it must be of exponential order. What do we mean by exponential order is, as limit n tending to infinity, the quantity e power minus st f of t dt must be finite in nature. So if I allow this n's to tend to infinity, limits s tending to infinity, so if the value is not going to be, t tending to infinity, if this value is not going to be finite, if it is going to move towards infinity, then we call that it is not of exponential order. Hence, if these two criteria, namely if the function is piecewise continuous in every interval which we define for t greater than or equal to 0, and if it is of exponential order, then the Laplace existence is guaranteed. Otherwise, if one of these is going to fail, then for those functions Laplace does not exist. So are there any functions for which Laplace does not exist? Yes, some mere examples are going to be the function called as tan t. Tan t is not going to be piecewise continuous. There is going to be a break. We know that this is going to be a function which moves from infinity to infinity, and again it is going to go from minus infinity to infinity, it breaks. So when I take a particular interval, there is a function is not going to be continuous in nature. There is going to be breaks. So you can say that tan t doesn't have Laplace for it. Say for example one more function, e to the power of t square. As my t tends to infinity, you have e to the power of infinity, in which case the function moves towards infinity. Hence it is not of exponential order, and Laplace does not exist for this function e power t square. So there are going to be certain cases for which Laplace does not exist, but there are going to be many cases for which Laplace exists and it is of practical use. So what is going to be the basic application of the Laplace? Laplace is going to be a very powerful mathematical tool that helps us to convert any differential equations into algebraic equations. So this makes a complex situation into a very simple quantity, and it finds its application in various fields like electrical circuits, control systems, signal processing, and so on, where this complex differential equation keep on arising in engineering problems. So to solve all such kind of things, Laplace is going to be a powerful mathematical tool. So to begin with, we will see how is going to be the basic formulas of this Laplace applied to problems. So we move on to apply the basic formulas to simple problems. The first formula says Laplace of e power minus at is 1 divided by s plus a. So, what will be my Laplace of e power minus 3t? This will give me, in place of a, I have it as 3. So, this will give me 1 divided by s plus 3. So, keep in mind, whenever it is going to be minus sign in the exponential, over here with your s, it becomes plus in nature. So, if it is minus here, it is plus here. Now, look into the second formula, Laplace of e power positive at. So, when it is going to be positive, what happens with the symbol over here inside of this s? This becomes negative in nature. So, what will be the value for Laplace of 2t? Now, this will be equal to 1 divided by s minus 2. So, when it is positive, over here it turns as negative. When it is negative, over here it turns as positive. Next comes Laplace of a constant. When you have a constant called as k, the formula turns out as k divided by s. So what will be Laplace of 1? Laplace of 1 will be 1 divided by s. What will be Laplace of 12? Laplace of 12 will be 12 divided by s. Now this can be further moved on to any t raised to the power of n. So what will be Laplace of t power n? It is n factorial by s power n plus 1. So what will be Laplace of t? Laplace of t will be equal to, what is the power of n over here? N is 1. So you have it as 1 factorial divided by s power 1 plus 1. So 1 factorial, we know that it is equal to 1. And this will give me s square. So Laplace of t is 1 by s square. What can be said about Laplace of t square? Laplace of t square will be 2 factorial divided by s power 2 plus 1. So that makes it as 3. We know that 2 factorial is 2 and hence this turns out to be 2 by s cube. Now, how can we identify this with a constant? Any constant 1 or whatever be the value of k can be written as t to the power of 0. Anything power 0 is going to be equal to 1. And so, what will be Laplace of t to the power of 0? It will be 0 factorial divided by s to the power of 0 plus 1. And we know that 0 factorial is equal to 1. So this now turns out as 1 divided by s. And 0 plus 1 makes it as s. That's why we have Laplace of 1 to be equal to 1 by s. Laplace of 12, this 12 can be taken outside or you can identify as 12 into t power 0. Hence you have it as 12 divided by s. So this is going to be the first set of formulas. Let us move to the next set of formulas. What is Laplace of sine at? Whenever I have sine at, it is going to be a divided by s square plus a square. What is Laplace of cos at? It is s by s square plus a square. So what is the difference we notice over here? When it is sine, the numerator has an a. When it is cos, the numerator has an s. And notice that the denominator is having a symbol with plus. So keep in mind, whenever you have sine, it is constant in the numerator, and for cos, it is s in the numerator. S sine doesn't take an s. S is not permitted. Cos is the one which takes the s. You can remember it in this way. No s means no s on top. Okay. So in which case can we find what is going to be Laplace of sine 4t? Yes. In place of a, I have it as 4. So this becomes 4 divided by s square plus 4 square. So it becomes 4 divided by s square plus 16. So Laplace of sine 4t is 4 by s square plus 16. So what can be said about Laplace of cos 4t? Now when it is cos, the numerator has to be not a constant but an s. So it is s divided by s square plus 4 square. So it is s divided by s square plus 16. So this is going to be Laplace of cos 4t. Now coming to the hyperbolic sine and hyperbolic cos. So we have Laplace of sine h of at to be a divided by s square minus a square. So when you compare a Laplace of sine and Laplace of sine h, what is the difference we notice? We notice that the denominator over here for sine contains a plus sign and the denominator for a sine h contains a negative sign. Similarly, for a cos h, the numerator is s, identical with your cos, but the denominator where you had plus over here turns out as minus. So, can we find what is Laplace of sine h of 4t? So, this will be equal to, when it is sine, you will not have s on your numerator, you will have a constant on your numerator. Keep this in mind. Okay, so it is s square minus 4 square. So it is 4 divided by s square minus 16. So what will be Laplace of cos h of 4t? So this will be, if it is cos, you will have to have a s in the numerator with s square minus 4 square, which gives you s divided by s square minus 16. So these are the first set of basic formulas we will be repeatedly using in our problems. So if we are comfortable to recollect all these of the things whenever it is required, then it will become the first easy step to solve any problem in our Laplace transform. Happy learning, keep learning. Thank you.